Aeroflow high-performance control valves feature state-of-the-art technology. The valves include globe and angle styles ranging from 1 to 16 inches in size with ratings of 150 to 4,500 pounds. Inlet vanes divert incoming flow evenly around the cage, minimizing turbulence to flow instability and improve flow capacity. Outlet vanes minimize turbulence to reduce noise and body erosion. Aeroflow also offers customization without sacrificing interchangeability. This makes custom design trims available and affordable. The Aeroflow T2 provides the speed, stability, and precision of hydraulically actuated valves at a fraction of the cost. 3 design features allow it to surpass the performance of current control valve technology. The Dps Positioner provides an ultra-fast, stable response. It supplies a pulse pneumatic output using a non-contact, direct-connected optical reader. This reader accurately and repeatedly measures valve stem position to plus or minus 1/1000th of an inch. The Magnum Series piston actuators provides extraordinary speed of response. The externally designed spring cartridge allows adjustability and failure position change without disassembly of cylinder. Finally, the T2 Pilot allows fluid pressure to provide shut-off thrust with high seat loading. The result is zero leakage at rated line pressure and temperature. The Pilot trim consists of 3 areas of pressure distribution and 2 areas of fluid flow movement. Pressure affects the plug in 3 areas. The control area, the largest, located at the top of the plug. The balance area under the plug, acted upon by the inlet pressure, and the seat area where outlet pressure occurs. The inflow pilot orifice moves the fluid from the balance area to the control area. The outflow pilot orifice moves the fluid from the control to the downstream side of the main plug. The position of the pilot plug will dictate outflow fluid rate from the control area. Air is transmitted by the positioner into the actuator. This initiates movement of the pilot plug. Small movements in the secondary pilot plug cause rapid movements in the main plug. In controlling the process set point, the main plug has 3 possible positions: movement downwards, movement upwards, and equilibrium. In a downward movement, the positioner sends air to the top of the actuator, moving the pilot plug downwards. The outflow rate is restricted by the pilot plug where the inflow exceeds the outflow. The pressure in the balancing area bleeds into the control area, forcing fluid pressure to build up on top of the main plug, causing a rapid downward movement of the main plug with no overshoot. In an upward movement, the positioner sends air to the bottom of the actuator, moving the pilot plug upwards. The outflow rate is increased by the pilot plug moving where the outflow exceeds the inflow. The pressure in the control area bleeds to the outlet of the main plug, forcing fluid pressure to build on the balance area, causing a rapid upward movement of the main plug with no overshoot. When the pressure in the control area equals the pressure in the balance area plus the seat area, and the inflow and outflow rates equal, the plug remains in position in a state of equilibrium. The following is a demonstration of Leslie's T2 versus traditional balance control valves, and will show why the T2 high-gain Aeroflow is more accurate and faster than any control valve in the world. On the right is a traditional balanced valve based on technology originating in the 50s and carried through to today. Key elements include a balanced trim, mandating a given stem and in-turn actuator size to deal with force imbalances, and a mechanical positioner. From any given manufacturer, the design configuration will be nearly identical, and therefore the installed performance will be consistent. To the left is an Aeroflow T2 high-gain valve, configured to give precision 20 to 100 times greater, while providing the potential for speed nearly 20 times faster, without compromising accuracy and stability. Both valves are set to run off of a 420 milliamp signal to show a comparison of response characteristics. The Aeroflow gives 420 milliamp feedback inherently, while the traditional valve requires a separate electrical position transducer. The position of both valves are being instantaneously captured on a computer monitor. We are now going through a series of 4 to 12 to 20 milliamp step changes to show a comparison of response characteristics. You can note the pulsing nature of the Aeroflow valve, where the internal integrating function pulses air pressure to bring the valve to its final position. In the traditional valve, a large rush of air is required to provide a proportional response. A tight, compact package makes this the valve of choice for heavy industrial applications.